Hello guys, welcome back to my YouTube channel. So today we are going to solve day 24 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3203. Find minimum diameter after merging two trees. Okay, so let's read the problem statement first. There exist two undirected trees with n and m nodes, okay, numbered from 0 to n minus 1 and from 0 to m minus 1 respectively. Okay, you are given two 2D integer arrays, edges of 1 and edges of 2 of length n minus 1 and m minus 1 respectively. Okay, so here see, this is my example number 1, right? So edges of length n minus 1, okay, and edges of 2 of length m minus 1, right? So here my n minus 1 is equal to n minus 1 is equal to here see this value. Okay, so 1 2 3, okay, 3, and my m minus 1 is equal to 1. Okay, and here if I move this 1 to other side, so my n is equal to 4 and my m is equal to 2, right? Simple mathematics. So here how many edges we have, how many nodes we have? We have nodes from 0 to n minus 1. Okay, so n is this, so we have nodes from 0 to 3, right? 0 1 2 and 3. Okay, so these are the nodes, right? 0 1 2 3, and here we have nodes from 0 to m minus 1, simply means 0 to 0 and 1. Okay, so these are our nodes. All right, so I hope that you guys are clear with this line. Okay, where edges of 1 a b indicates that there is an edge between nodes a and b in the first tree, and edges of 2 uv indicates that there is an edge between nodes u and v in the second tree. Okay, simple now. So here 0 to 1 there is one edge, okay, in the second tree, and here 0 to 1 there is one edge, 0 to 2 there is an edge, 0 to 3 there is an edge. Okay, you must connect one node from the first tree with another node from the second tree with an edge. Okay, there must be some edge in between these two. Okay, so we have to connect. Okay, so there is one additional edge that I'm going to use, right? We have to return the minimum possible diameter of the resulting tree. Okay, and what is the diameter of tree? So here just remember this keyword minimum possible diameter. Okay, this is what we need to return. Okay, and what is diameter? The diameter of a tree is the length of the longest path between any two nodes in the tree. Okay, diameter of the tree is the length of the longest path between any two nodes. Okay, so here what is the diameter of this tree? So here see, this node, if I pick this node 3 and 2, the diameter is going to be 2. Okay, this is maximum na? If I take these two nodes 3 and 2, I will get 2. Okay, if I pick this 3 and 1, again I am getting only 2 edges in between them, right? So this is the diameter of tree. Okay, so diameter of a tree is the length of the longest path. Okay, so this is the longest path now, 3 to 0 and 0 to 1, or 3 to 0 0 to 2, or 2 to 0 then 0 to 3, 2 to 0 0 to 1. Okay, this is the longest path. Okay, so this is nothing but the diameter of a tree. Okay, so before moving to the actual question, okay, so let me clear a few things. Okay, so here let's say I have a tree like this. This is one node, this is two node, okay, this is three node, okay, this is node 4, and this is node 5. Okay, and I want to join this tree, let's say tree A with tree B. Okay, and my tree B is like this, 6 7 8. Okay, so now if I want to join these two trees, if I create a edge, okay, this is my leaf node. Okay, this is my leaf node. Okay, so since this node is connected with just one other node, okay, and this is also one leaf node. Okay, leaf node, right? Because this node is connected with just this other node. Okay, single node. So this node is connected with this one. Okay, this node is connected with this one, but if you see this two is connected with this 1 and 3. Okay, so definitely they are not our leaf nodes. Okay, so this can be our leaf node, this can be our leaf node. Okay, so if I try to join these two trees based on their leaf nodes. Okay, so let's say I have created one edge like this. So in that case I will get the max height, right? So here see 1 2 3 4 5 6 7. Okay, 7. But what we need to do here, we have to return the minimum possible diameter of the resulting tree. Okay, so definitely this is not the best answer. Okay, if we join the trees on the leaf nodes. Okay, so definitely this is not going to give me the best answer. Okay, so see, length is so high, right? So high. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 8, 8 to 7, 7 to 6. Okay, so definitely this is not the best case, right? So I can't join the two trees on the leaf nodes. Okay, so this is my point 1. Okay, point 1, do not join the trees, okay, on their leaf nodes. Okay, because in that case we are going to get the maximum diameter, not minimum possible diameter, maximum diameter. Okay, so this is one point. Okay, clear? Now here I can do one thing now. Instead of this, I can join the tree based on the center of this. Okay, so this is the center of this one, right? And this is 7 is the center of this one. So if I join trees here, then what is the height I'm going to get? So previously we are getting height something around 7, right? 1 2 3 4, then 5 to this. Okay, 1 2 3 4 5 6 7. So 7 was the height we are getting previously. Okay, now if I join the tree like this, okay, based on the center, okay, centroid, or I can say centroid, right? So if I join them like this, okay, so now just calculate the max height. So this is 1, this is 2, this is 3, this is 4. Okay, so max is 4 I'm getting, right? 4 I'm getting. Okay, here see 1 2 3 4, again 4. If I move, start from here, 1 2 3 4, again 4. Okay, so now here see I'm getting 4 only, right? You can start from any point now. 1 to 2, 2 to 3, 3 to 7, 7 to 6, again 4. Okay, so from one node to another node I can reach in just 4. Okay, but here see one more thing. 1 to 2, okay, this is 1. 2 to 3, this is 1. Okay, 3 to 4, this is 1. And 4 to 5, this is 1. So here also I'm getting 4 only. 1 2 3 4. Okay, so here also I'm getting 4. Okay, yeah, everywhere I think I'm getting 4 only, right? 1 2 3 and 4. 1 2 3 4. Yeah, everywhere I'm getting 4. Okay, so what is my first point? So first point is, don't join the two trees on the leaf side. Okay, on the leaf side, because in that case you are going to get the maximum diameter. Okay, so try to join the trees on the centroid. Okay, on the center of them. Okay, so just treat this 3 as the root of this one. Okay, and this 7 is the root of this one. Okay, so this is one point. Okay, all right. So now how we are going to know that this 3 is our root? Okay, how we are going to know that this 3 is my root, or how we are going to know that this 7 is the root? Okay, so let's understand this. Okay, so I'm discussing about point 2 here. Okay, so let's say I have 5 nodes. 1 2 3 4 and 5. Okay, so now in this case, this is my leaf and this is my leaf. Okay, right? And 1 is connected with just 2, so here I'm writing 1. 2 is connected with 1 and 3, I'm writing here 2. Okay, 3 is connected with 2 and 4, I'm writing 2 here. 4 is connected with 3 and 5, I'm writing 2 here. 5 is connected with just 4. Okay, so here I'm writing 1. Okay, so now here if you see carefully that the values, okay, so here this node is having one value and this node is having one value. Okay, so the edge count of this node and this node is 1. Okay, that simply means that these nodes are nothing but my leaf nodes. Okay, so treat them as leaf nodes. Okay, if my edge count is just 1. Okay, so if that is the case, Now what you need to do here, break this connection. Okay, break this connection. Okay, this is just for representation I'm saying. Okay, so if you break these two connection, now this count and this count will become 1, right? This count and this count will become 1. Okay, so 2 is connected with just 3, 3 is connected with 2 and 4 is connected with just 3. Okay, 1. Now here you are going to treat then this 2 and this 4 as leaf, right? Count is just 1. Okay, so now break this connection. Okay, and here break this connection. Okay, so that's it. Okay, so now this 3 is the left out part. Okay, this 3 is the left out part. Okay, this 3 is not connected with anyone and this 3 is the left out part. Okay, we just break this connection, break this connection. So that simply means that 3 is the root of this tree. Okay, 3 is the root that we are considering. So now if I draw the tree like this, 3, and here I'm writing 2, and here I'm writing 1. Okay, and here I'm writing 4, and here I'm writing 5. Okay, so now if I'm treating these 3 as my root, okay, then in that case, okay, if I calculate the diameter, okay, so max diameter, so here I'm getting just 2, here also I'm getting just 2. That's it. 3 to 2, 2 to, okay, this one 4 to 5, and here 4 to 3. Okay, just 2. Okay, so here this is nothing but my centroid or my root. Okay, so this is the case of my odd number of nodes. So in my odd number of nodes, there is always going to be just one center. Okay, in the odd number of nodes. Okay, so this is my point 2. Okay, now let's move to the point 3. So now let's say we have the nodes like this: 1, 2, 3, 4, 5, and 6. Okay, now if I just write the edge count, so here 1, 2, 2, 2, 2, and 1. Okay, so first break this connection. Okay, 1 and 6 are the leaf nodes. Okay, break this connection. All right, so now this is going to become 1 and this is going to become 1. Okay, 1 and 1. Now after that, break this connection, break this connection. Okay, so now if we break this connection, then this is going to become 1 and this is going to become 1. Okay, 1 and 1. Okay, so okay, right, 3 and 4 are connected. Okay, we break this connection. Okay, so now in this case, just stop here, just stop here. All right, in even number of nodes, just stop here. So I am going to run one while loop while my number of nodes are greater than 2. Okay, only till then I'm going to do this, break this. Okay, then move further, break this. Okay, so if my n becomes 2, okay, or 1, then we have to stop, because if it becomes 1, then simply means that we have got this. Okay, in odd number of nodes we are going to get this. Okay, just 1, but in even number of nodes we are going to get this 3 and 4. Okay, so now in that case, what you need to do here, so now let's draw the tree. Okay, 3, 4, and here 5 and 6. So we have two centroids here, two roots. Okay, in case of even number of nodes, 3 and 4. Okay, here 2 and here 1. Okay, so now just calculate the height. Okay, so if you treat this 3 as your root, then here you are getting 2. Okay, in the left side, in the right side you are going to get 3. Okay, so 3 is the maximum, so let's take this 3. Okay, now if you consider this 4, okay, if you consider this 4, then in the left side you are going to get 3, in the right side you are getting 2. Okay, so we are going to consider 3 as the height of this tree. Okay, 3 as the height of tree. Okay, so you can try to consider anything. Okay, 3 or 4 as your root, and you will get the height as 3. Okay, so this is clear. So 3 or 4 you can consider anyone as our center. Okay, so this is one thing. So from point 2 and 3, one thing is clear, that for odd number of nodes we are just going to get one root, and for even number of nodes we are going to get two centroids or two roots. Okay, we can treat any one of them as our main root. Okay, so this is another thing, right? So I hope that you guys are clear. Okay, so we have to join a tree A with tree B. Okay, if it is even number nodes, then from 3 or 4, any one position. Okay, all right, this is clear. Now let's move to next point 4. Okay, so now see this tree. Okay, so here edges of 1 is like this. 0 is connected with 1. Okay, so let me just draw it somewhere. 0 is connected with 1. Okay, 0 is connected with 1. Okay, 2 is connected with 0. Okay, so 2 is connected with 0. Okay, 3 is connected with 2. 3 is connected with 2. Okay, 3 is connected with 6. 3 is connected with 6. Okay, 8 is connected with 7. Okay, so here I'm writing 8. 8 is connected with 7. Okay, and 4 is connected with 8. 4 is connected with 8. Okay, let me write here 4. Okay, now I'm discussing point 4. Okay, 4 is connected with 8. Then 5 is connected with 4. Okay, and then 3 is connected with 5. Okay, and 3 is connected with 9. Okay, 3 is connected with 9. Okay, so this is my tree. Okay, this is my tree. All right, so now here in this case, how you are going to first find out what are your uh, roots. Okay, so here if you calculate, okay, so 1 is having uh, degree 1. Okay, number of edges connected with 1, just 1. Okay, 7 is 1, 6 is 1, and 9 is 1. Okay, all other are not 1. Okay, so treat this 1, 7, and 6 and 9 as leaf nodes. 1, 7, 6, and 9 as leaf nodes. Okay, now break the connection among them. Okay, so break the connection. All right, so here we just break it like this. Okay, 176. All right, and here let me just move it a little bit up. Okay, and here this 9. Okay, so I break this connection. Okay, so I break this connection. Okay, 1769. Okay, so now if you see in my tree, this 0 is having a degree 1 and 8 is having degree 1. Okay, that's it. Okay, so now 0 and 8, okay, are my leaf. Okay, so now break the connection among them. 0 and 8. Okay, I break this connection. Now 2 and 4 having degree 1. Okay, number of edges connected with 2 and 4 are 1. Okay, break this connection. All right, so let's break this 2 and 4. Okay, now 3 and 5 are there. Okay, so you can take any one of them as your root. Okay, now 3 and 5 are there, so you can take any one of has there as your root. Okay, so here how many number of nodes we have? 1 2 3 4 5 6 7 8 9 10. Okay, even number, so that is why we are going to get two centroids. Okay, 3 and 5, so you can pick anyone. All right, okay, so this is one thing. Now let me just do Control Z. Okay, so let me just remove it, whatever I removed. Okay, so this is my tree, right? And we know that 3 and 5 3 and 5 can be my root. Okay, so now first of all, let's calculate the diameter of this tree, diameter of this edges of one tree 1. Okay, what is the diameter of tree 1? So here if you calculate, so you will get 1 2 3 4 5 6 7. 7 is the max diameter that you are going to get from any one node to another node. Okay, 1 to 7 I am seeing maximum distance. Okay, I don't see max distance from 1 to 6 or 1 to 9, but 1 to 7 I think I am going to get the max distance, right? So 1 to 0, 0 to 2, 2 to 3, 3 to 5, 5 to 4, 4 to 8, 8 to 7 is 7. Okay, 1 2 3 4 5 6 7. Yeah, 7 is there. Okay, 7 is the nothing but diameter of this tree 1. Okay, so I'm writing d1. Okay, diameter of tree 1 is 7. All right, now see my tree 2. Okay, so here 0 to 1 we have. Okay, 0 to 2 we have, and 0 to 3 we have. Okay, so here if you see carefully, uh, see carefully. So how many number of nodes we have? 4. Okay, so now here in this case what is going to happen? Okay, so here this is degree 1, this is degree 1, this is degree 1. Okay, 0 to 1, and this degree is 3, right? 1 2 3. Okay, so now here this is a case where 1 to 1 edges are there. Okay, 1 to 1 edges are there. There 1 to 2, then 2 to 3, then 3 to 4, then 4 to 5. Okay, 6 to 7, then 7 to 8. Okay, okay, so here just 1 to 1 edge, right? But here here also and here also. Okay, so here see 1 to many edges are there, right? 0 is connected with 1, 0 is also connected with 2, 0 is connected with 3. Okay, so here this degree is beneficial, right? If I'm writing degree here, 3 is connected with just 0, so here I'm writing 1. 2 is connected with 0, I'm writing 1. 1 is connected with 0, I'm writing 1. Okay, so here I know that 1 2 and 3 are going to be my leaf nodes. Treat them as leaf nodes. Okay, what? 1 2 and 3. Okay, 1 2 and 3. So if I treat them as my leaf nodes, I remove the connection. Okay, so in the end 0 is there. Okay, just 0 is left out. Okay, so take this as my root. Okay, so see how beneficial is this one. Okay, degrees. So 0 is my root. Okay, in this case, so here let me draw this tree. Okay, 0 and 1 2 and 3. Okay, so if I calculate the diameter of this one, diameter of d2, so it is going to be just 2, right? So 0 to 1 there is connection, 0 to 2, 0 to 3. Okay, so 1 to 0 0 2. Okay, 2. Okay, 2 is going to be the my diameter. Okay, so now here 2 is a diameter, and this tree has 7 as diameter. Okay, d1 is 7, d2 is 2. Okay, so I told you that based on the center point I have to join them. Okay, so 0 to 3 I can join, right? So here let's say I join this 0 to 3. Okay, so now see here, one this thing carefully. So 3. Okay, and here I'm getting the max length. Okay, 7. Okay, 3 to 2, 2 to 0, 0 to 1, 1 2 and 3 only. But if I follow this path, 1 2 3 4. Okay, so now let's follow this path then. 7 to 8, 1 2 3 4 5 6. I'm getting 6 here, right? I joined these two trees. Okay, and now I'm calculating the distance. Okay, it's from 7 to this tree is 1. I'm getting what? 6. 1 2 3 4 5 6. Okay, 6 is the distance that I'm getting after joining. Okay, 6 is the distance. Okay, I joined these two. Why am I returning 7? Because diameter meter of tree 1 is still greater, right? And what we need to return, we need to return the minimum possible diameter of the resulting tree. So this complete tree as a whole. Okay, this complete tree as a whole, if you see, so here if I'm moving from 1 to 7 of the same tree, okay, t1, I will get 7. Okay, and after joining, if I'm joining, then still I'm getting lesser only. Okay, if I treat this 3 and 0 as a center point. Okay, so here output is 7, right? Clear? So yeah, this is clear. Okay, so here don't get confused, like I'm saying, right, 0 1 2 and 3. Okay, so here you are going to say that we have 4 nodes, but why we are not returning 2 as a sentence? Okay, so that is the reason that we are going to use this degrees. Okay, in degree out degree. Okay, but if you follow this example, okay, so I will add the link of this question in my YouTube channel. Okay, and I posted today morning as well. Okay, in the post section, this question solution. Okay, so if you I will suggest you guys to first solve this problem. Okay, this is medium level problem. Okay, try to solve it, and you can use the same logic that you are going to use here in today's problem as well. Okay, so just go over this problem as well, minimum height trace. All right, so in that case I have explained this, that for odd number of nodes we are going to get a single root, and for even number of nodes we are going to get 2 roots. Okay, okay, so in that I think we have just one-to-one connection. Okay, let me just move to this question 1 second. Okay, so yes. Okay, so this was the solution part. Okay, here for this one. All right, So here you will find out, right? Okay, so this is nothing but minimum height tree. Okay, so we have n is good 4 given and edge is given to us. Okay, and we have to find the minimum height of the tree. Okay, so just try to solve this question as well. Okay, so yeah, all right, so this is one thing. Okay, now after that, okay, this is nothing but my uh, another example. Okay, so now let's move to the main example. Okay, example number 1. So here for this tree, the diameter is 2. Okay, diameter is 2. Okay, d1 is 2, and for this tree diameter is just 1. Okay, and if I join these two trees, okay, so if I join these two, so let's say this is one edge. Okay, I join this like this. Okay, so what is the distance I'm getting? Okay, so d1 and d2, which is max? Max is 2 only. Okay, and here if you consider the height, okay, so if I treat this 0 as my root, so height of this tree is nothing but 1. Okay, and here height of this tree is also 1. Okay, so 1 plus 1 plus 1, total 3. 1 plus 1 plus 1. Okay, so these three ones, right? This is one node, one edge, this is one edge, and this is one edge. Okay, this is one edge, this is one edge, or this is one edge. Okay, 2 to this one. Okay, if you see the distance, you will get 3 only. 1 to 1, if you find the distance, max distance, it is going to be 1 only. Okay, so we have to return the minimum possible diameter of the resulting tree. Okay, and diameter is nothing but the longest path between any two nodes in the tree. Okay, so longest path is nothing but we have to make this as minimum possible diameter. Okay, and diameter is nothing but the longest path. Okay, that's a simple meaning. All right, now see this example number 2. Okay, so here these are the different two edges given to us, right? Okay, so here let's now first we need to find out our uh, root. Okay, so how we are going to find out our root? So here see in degrees 1 1 1 for this one, 1 for this one, 1 for this one. Okay, so remove this, remove this, remove this, remove this, remove this, remove this. Okay, now we are left with 2 and 3 and 0. Okay, so this is having in degree 1 in degree 1 now, and this is having in degree 2. Okay, remove this, so 0 is the root. Okay, for this one. Okay, and how many nodes we have? 1 2 3 4 5 6 7 8. Okay, we have 8 nodes, but still I'm getting this as center. Okay, here, right? Okay, now here this is my leaf, this is my leaf. Okay, degrees 1. Okay, and remove it, remove it, remove it, remove it, remove it. I'm left with this. Okay, this part only. Remove it, remove it. I'm left with 0. Okay, so 0 is this. Okay, so let's join these two trees. Okay, 0 with this 0. Okay, so I have joined this. Okay, so now max distance. Okay, so if I start from here, let's say, so I will get 1 2 3 4 and 5. Okay, so 5 is the maximum output that I'm going to get in this case. Okay, after joining. Okay, and the height of this tree is nothing but, if I consider this 0 as my root, so height of this tree is nothing but 2 only, right? 1 and 2. Okay, 1 and 2. 2 is the max height, and here this tree also 1 2 2 only. Okay, after joining them, so here 0 0 I'm joining them. Okay, so I'm getting nothing but 3, right? And yeah, this is one thing. Okay, all right, okay, all right, yeah, that is it. So now can we move to the coding part? Yeah, let's try. Let's move the coding part. Okay, so same thing I'm going to write, and with code also I'm going to explain few things. All right, so don't worry. So first of all, what you need to do here, uh, we have two edges given to us, right? So here what I'm going to do, first we have to create the adjacency list. Okay, so adjacency list simple means that this 0 is connected with 1. Okay, 2 and 3. Okay, this is something like this. 1 is connected with 0, 2 is connected with 0, and 3 is connected with 0. Okay, so what I'm going to create, I'm going to create the adjacency list like this. Okay, so 0 and 0's neighbors, 1 and 1's neighbor, 2 and 2's neighbor, 3 and 3's neighbor. Okay, something like that. So yeah, so here first create list of integer, okay, array, and let's name it as adjacency list 1. Okay, and here I'm just going to call this method build tree. Okay, and in this build tree I'm just going to pass the edges. Okay, so this is the first thing that I'm going to do. Okay, so now let me write the code for this build tree, okay, side by side. So here I am going to write the code for build tree. Okay, so this is nothing but going to create the adjacency list for me. Okay, so here public list of integer, okay, and here build tree, all right, and here int of edges. Okay, so I'm going to call this same method, okay, build tree, for both edges 1 and edges 2. Okay, so here right now I'm passing nothing but edges of 1. All right, okay, all right. And yeah, one more thing here, no, don't get confused with this 5. Okay, number of nodes 5, so we are getting just one root, and number of nodes if 6, then we can get 2 nodes. Okay, we can get, okay, so here just one thing, that max number of centers that we are going to get is going to be 1 or 2. Okay, so just for this purpose only, okay, I've explained this. So in case of odd number of nodes, if all nodes are connected like this only, single connection is there, 1 to 2, 2 to 3, 3 to 4, okay, something like this, then 1, okay, or 2. Okay, so this is a case. Okay, so always there is possibility that we are going to get only one root or two roots. Okay, so if you see in graphs like this, okay, where we have multiple connections from one node, okay, to another, here also we are just getting one root, okay, or sometimes two roots. Okay, so here we are getting 3 and 5. Okay, so that's the only reason. So here we are getting just single. Okay, we are never going to get more than 2. Okay, so that's the main reason, right? Okay, so here whatever the edges that we are passing, first let's calculate the length of that. So int m is equal to edges, okay, dot length plus 1. Okay, so this is my m. Okay, and create one adjacency list. Okay, so adjacency list of integer type. Okay, and here adjacency list new list, and here I'm passing m. Okay, side of this list. Okay, so now for int I is equal to 0, I is less than m, I plus plus. Okay, and here adjacency list of I. Okay, so now we know we have m minus 1 nodes, right? So that's the reason. New array list. Okay, so this is done. So now we have to fill the values. So let's just iterate over all the edges. Int edge, okay, in the edges, okay, whatever the edges that I'm passing. So here adjacency list, okay, here in place of edge of 0, okay, 0 dot add edge of 1. Okay, edge of 1. All right, now just copy the same line, here, edge of 1. Okay, and here we are going to write 0. Simple means that we have a relation from 0 to 1, then same way we have relation from 1 to 0 as well. Okay, that is why I'm writing like this. All right, and here simply return adjacency list. Okay, that's it. Okay, that's it, the code for creating the adjacency list. Okay, that's it. Okay, so here first we are passing edge is 1. Okay, and we are going to get the adjacency list of 1. All right, so now here few more things let's do. So same way I have to create the adjacency list 2 as well. Okay, so let me just copy this, paste this line here. Okay, adjacency list 2, that's it, that's only change. Okay, I'm going to call this build tree, and now instead of edges of 1 I'm passing edges of 2. Okay, this is done. All right, so now after that my next thing is going to find the root. Okay, what is my root? All right, so here I'm going to store the values of my root in a array list. Okay, so here list integer root 1 is equal to new array list. Okay, same thing, copy this line, same thing, we need to find the root for the edges 2 as well. Okay, so here I'm going to write root 2. Okay, now we have to get the diameter. Okay, so what is diameter? Diameter is the length of the longest path. Okay, so here int diameter of tree 1. Okay, diameter of d1 or diameter 1. Okay, whatever you want, right? So here I'm going to call one method get roots. Okay, and in this get roots I'm going to pass the adjacency list that I have created. Okay, and I'm going to pass the root of 1. Okay, these are the two things that I'm going to pass. Okay, and same way copy this line and paste it here. Okay, so here I'm getting diameter 2. Okay, and get roots adjacency list of 2 I'm going to pass, and root 2 I'm going to pass. Okay, so now let's write the code for this one. Okay, get roots. So here write public. Okay, so I'm going to get the diameter from this get roots. Okay, so here type I'm going to give int. All right, and here get roots. Okay, and inside this we are going to pass the adjacency list. Okay, so here let me just copy this line. Okay, so list integer and adjacent list only. Okay, note 1 and 2 I'm not mentioning. Okay, because I'm going to use the same thing for both list 1 and list 2. Okay, so here I'm not mentioning anything. Okay, and after that we are passing root 1. So here list of integer root, just write until here. Okay, root, that's it. All right, so here inside this now I am going to write the same code. Okay, the code that I've explained here. Okay, so little bit it's going to be similar. Okay, this part. Okay, so I suggest you guys to watch this video as well. Okay, it is there in my YouTube channel. Okay, and but you can solve this question right now. Okay, I'm here also explaining the same things, but I want you guys to solve this question as well. Okay, don't forget to solve this one, it's very important, and this question is asked in Google as well, this question, medium level. Okay, now here take height as 0. Okay, initially height is 0. Okay, so now what I'm going to get, I'm going to get the diameter. Okay, from here. So here now take the n as the adjacency list dot length. Okay, adjacency list dot length. All right, and now inside after that we have to take the edge count. Okay, number of edge count we have to count, right? So edge count is equal to new int n. All right, and then after that we have to run one loop for int I is equal to 0, I is less than n, I plus plus. Okay, now here, now see carefully. Okay, now we are going to check the leaf nodes. Okay, so I am going to iterate over my adjacency list that I am passing here. Okay, so if adjacency list, okay, of I, okay, dot, okay, size, okay, if the size of this adjacency list is equal to 1, that simply means that it is nothing but my root. Okay, so here in my root, okay, I have to add the I index. Okay, I index on my node. Okay, so this is what we need to do. All right, and here same way we have to keep track of the edge count as well. So how we are going to keep track of edge count? So 0 edge count is 3 now, so this size I will get simply 0's edge count is 1's edge count is 1, 2's edge count is 1, 3's edge count is 1. Okay, so here edge count, okay, of I is equal to adjacency list of I dot size. Okay, so here I'm just going to pass the edge counts. All right, so this is done. Okay, now after that, okay, this is where my for loop ends. So now we have to write this part, okay, while n is greater than 2. Okay, this part, so that is what I'm going to implement here. While, okay, so I have to run this loop until my n is greater than 2. Okay, so if it becomes 1 or 2, then simply exit from it. Okay, 1 means that we have single root, 2 means that we have two roots. Okay, so that's the simple meaning. Okay, and we know that at maximum we are just going to get two roots. Okay, it is not possible to get more than two roots. Okay, so that we know already, right? So here now if my n is greater than 2, okay, that simply means I'm going to break few things. Okay, so here I'm just going to increment the height plus plus. All right, now I'm going to update my n as n minus root dot size. Okay, I have to remove all the leaf nodes. Okay, that is what I'm going to do. Okay, now here I'm going to create one array list next. Okay, list of integer next is equal to new array list. Okay, and now we have to just run one loop for int size is equal to 0, size is less than root dot size. Okay, and size plus plus. All right, so here what we are going to do, we are going to create one variable int top. Okay, and in top I'm just going to store the size. Okay, root dot get the size. All right, so now we have to iterate over all the neighbors, okay, of this top. So for int neighbor of this, okay, so here adjacency list. Okay, and here I'm just going to pass the index as top. Okay, so for this one, okay, so here we have to first decrement the edge count as well. Okay, so edge count of neighbor. Okay, we have to reduce the edge count of edge count of neighbors as well. Okay, neighbor minus minus, right? So see here, we are removing the connection, right? So here for previously it was 2 now, so here when I remove the connection, so this edge count of the neighbors are reduced to 1, right? So that's what I'm doing here, right? And if side by side I'm going to check if edge count, okay, of my particular neighbor. Okay, so if edge count of neighbor, okay, is going to become 1, is going to become 1, then in that case only we have to add them in our next list, next dot add. Okay, next time these are going to become my new roots. Okay, so here neighbor I have to write. Okay, and yeah, that's it. Okay, so this thing we have to do, right? And then we have to clear our root. Okay, existing root, we are just going to clear it, and in the root we are going to add the next elements, all next elements. Okay, add all next. Okay, next time these are our leaves. Okay, then for those leaves take the neighbors. Okay, that's what we are doing here. So here once this while loop ends, so in the end definitely we have just one root or two roots. Okay, so here I'm just going to write if root dot size. Okay, if do root dot size, okay, if it is equal to 1, okay, if it is just 1, then in that case just return 2 into height. Okay, and if it is 2, okay, then here just return 2 into height plus 1. Now why we are doing this? Okay, that is the question. All right, so see here 1 2 3 4 5. Okay, so here we have just a single root. Okay, in this case we have just single root. Okay, so here first time initially my height is 0. Okay, so when I my n is also greater than 2 right now. Okay, so I remove these two connections. Okay, these two. All right, so my height is going to increment to 1. Okay, then I remove these two. Okay, then my height is going to increment to 2. Okay, so here in this case we have single root. Okay, so can I say that my diameter is nothing but 2 into 2 4. Okay, so see here height is 2, diameter is 4, so 1 2 3 and 4. 4 is the diameter, correct. Okay, so 2 into height we are doing. Now in case of even number of nodes, okay, 1 2, okay, 3 4 5 6, because we are returning diameter now. Okay, so initially my height is 0. Okay, so first I'm going to remove these two, so my height is going to become 1. Then I'm going to remove these two. Okay, my height is going to become 2. Okay, now in the end I'm just going to left with these two. Okay, so height is 2, but my root dot size is also 2. Okay, it is not equal to 1, that simply means 2. So now can I return my diameter as 2 into h plus 1, that is nothing but 2 into 2 4, 4 plus 1 5. Okay, so yeah, I can return 5, right? 1 2 3 4 and 5. Okay, that's the simple meaning. Okay, so this is done here. All right, so now, okay, so here we get the diameter. Okay, so now how we are going to get the height? Height is nothing but height of 1, it is going to be nothing but dividing this diameter by 2. Okay, diameter of 1 with 2. Okay, this is my height of this tree, and this is my height of this tree. Okay, int height of 2, and here I have to write diameter 2 divided by 2. Okay, so in this way I'm going to get the height. All right, now only 2-3 lines are pending, that's it. Okay, nothing else. Now here, okay, so now here we get the height. Okay, so now here if my root 1 dot size, okay, if my root 1 dot size is equal to 2, okay, then in that case just increment the height 1 plus plus. Okay, and if same line, if root 2 dot size is equal to 2, then increment height of 2 plus plus. why? Tell me why. Okay, so see here. So in first case, okay, if you see here, we are going to get the diameter as 4 here. Okay, we are going to get diameter as 4. So 4, and if I divide this 4 with the 2, I am getting my height as 2. Okay, that is right. Okay, so 2 is the height I'm getting. Okay, and in this case we have odd number of nodes, so I'm not incrementing the height, okay, of height 1 plus plus. Okay, it is not equal to 2 root size. But here in this case my diameter is 5. Okay, when I'm going to divide it with the 2, I will get 2 only. Okay, 2 to 2 4. Okay, here still 1 left, right? 2 only. So if we have two roots, then I'm adding height as 3. Okay, because here 1 2. Okay, if I'm treating this as my root, so here 1 2 3 is the height. Okay, if I'm treating this as my root, then 1 2 3 is the height. Okay, so that is why we are incrementing the height. Same example. Okay, two roots, if we have even number of roots, then we have to increment the height. Okay, because 5 divided by 2, still 1 is left, right? Still 1 is left, so that's the reason. Okay, height 2 plus plus. Okay, now in the end just one line left. That's it. Return math.max. Okay, and in the starting only itself I have explained this line, math.max of diameter 1. Okay, diameter 1, diameter 2. All right, and here or height 1 plus height 2 plus 1. Okay, so this line I have explained in the starting itself. Okay, so if you see carefully this example, here diameter 1 was 7. Okay, in this example diameter 1 was 7. Okay, and if after joining these two I was getting just 6. Okay, so in that case this diameter 1 is taking the priority, right? So that's the only reason. Okay, so now, and yeah, this is one thing. Okay, now let's run it and see if there any code issue. We try to fix that. So yes, there are some issues, so let's try to fix that. Okay, yeah, here line number 15, here spanning list. Okay, this I have added, and root 1 dot size, line of 51 59. Okay, where is 59? Here. Okay, so here we have to use like this now, root 1 dot size, 2 dot size. Okay, any other issue? Line number 63. Okay, let's run it again. All right, where is this? Line 42. Line 42. Oh, here also I missed this. Okay, let's run it again. So see, our test cases has been accepted. Okay, and yeah, here hint 1, if you find out, suppose that we connected node A in tree 1 with node B in tree 2, the diameter length of the resulting tree will be the largest of the following three values: diameter of tree 1, diameter of tree 2. Okay, the length of the longest path that starts at node A and that is completely within tree 1 plus the length of longest path that starts at node B and that is completely within tree 2 plus 1. Okay, so yeah, very similar to this line. Okay, that I have written here. Okay, so now let's submit it. See, so our solution is accepted, right? And we are here. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.